Hi students, coming to the next concept in the intermediate code, that is a 3-address code. So the intermediate code can be represented as the abstract syntax tree and polish notation and then 3-address code. So we already seen what is this abstract syntax tree and the polish notation. There we have explained about the postfix expression. Now let's see the 3-address code. So it is an intermediate code. It is used by the optimizing compilers. So this 3-address code will be used by the optimizing compilers. In 3-address code, the given expression is broken down into several separate instructions. So whatever the expression that is they are given, that expression is broken down, divided into several separate instructions. These instructions can easily translate into assembly language. So why we are brokening the expression into several separate instructions? So whenever you have broken the instructions, then it can easily translate to assembly language. Okay, suppose if you didn't understand any topic, what you will say, you will just divide the topic into several topics. So if you understand point by point, if you read point by point, then you can easily understand. In the same way, the compiler, if they want to convert the source code into high level language into assembly level language, this 3-address code broke the expression into several separate instructions so that it can easily translate into assembly language. Each 3-address code instruction has at most 3 operands. The thing you have to remember, that 3-address code is having at most 3 operands. At most. Beyond that you can't, okay, only at most 3 operands. That's it. It is a combination of assignment and a binary operator. So the 3-address code, in 3-address code, there is at most 1 operator on the right side of an instruction. The thing you remember that at most 1 operator should be right side of an instruction. So right side of an instruction, there should be at most 1 operator should be there. That you have to be remember that. So let's see here. X plus Y star Z. So how I'm going to divide these expression into several separate instructions so that it can easily convert into assembly level language. So I'm just breaking T1 is equal to Y into Z. So I'm just taking this Y into Z as T1. So now T2 becomes X plus T1. Okay, T2 becomes X plus T1. So instead of taking these 3 operands, just here only 1 operand is there. And these 2 are the temporary names for the compiler generator. Okay, so now let's take these examples. So this much of expression I'm breaking down into separate parts. Okay, let's see. The 3-address code for this equation is, let's take T1 is equal to B minus C. Next, T2 is equal to, just take this, A into T1. Because B minus C is T1. Okay. So now T3 is equal to, now take complete here, A plus T2. Instead of writing complete this equation, I'm just writing T2. Okay. Instead of this, I'm just writing T2. Now T4 is equal to D into, this is T1. And T5 is equal to T3 plus T4. Okay, so just breaking the expression into several separate instructions so that the compiler can easily convert into assembly level language. So this is the main use of the 3-address code generator. Okay, so this 3-address code generator is of different types. One is the quadruples and the triples. Okay, now let's see what is this quadruples. The 2 data structures for the 3-address code is, one is quadruples and next is triples. Okay, so the quadruples, it has a 4 fields. Just remember that the quadruples is having, quad means 4 fields will be there, 4 fields. So that is the 4 fields are operator, okay, source 1, source 2, and destination, that is the result. The four fields are, one is the operator and the source 1, source 2 and the destination, nothing but the result. Okay, so let's take the example for this quadruple. Here I am taking example A is equal to minus B star C plus D. So this is an expression. The first thing is you need to convert this expression into 3 address code. So what is the 3 address code for this expression? Let's take T1 is equal to first minus B. T2 is equal to, let's take C plus D. And T3 is equal to, add these both two. That is T1, multiply both T1 into T2. Okay. So now T3 consisting of complete expression. But I want A is equal to. So this is one operand. So finally A is equal to T3. So I converted the expression into simple A is equal to T3. So instead of writing this complete expression, I just written A is equal to T3. So this T3 is nothing but T1 into T2 and T2 is C plus D and T1 is equal to minus B. Okay. So I converted into 3 address code. Now I have to make it as a quadruple. Quadruple means these statements are represented as a quadruple like this. Let me show you the quadruple. Quadruples representation. Let's take the operator. Okay, operator, source 1, source 2 and the result or destination. So the first reference 0. So just check these productions. So first operator is minus B. Okay. So minus is the operator and the source 1 is the B. There is no source 2 and the destination is the T1. So just take the first production. The first production is U minus and the source is B. There is no source 2 and the result will be T1. Next take the second production. In the second production, the operator is plus, source 1 is C and source 2 is D and the result is stored in T2. So operator is plus, source 1 is C, source 2 is D and the result is stored in T2. Next one, the third production. In the third production, the operator is into, source 1 is T1, source 2 is T2 and the result will be stored in T3. Star T1, T2, T3 and the final one. So the final, what is this fourth one? The fourth one, the operator is equal to, source 1 is T3, source 2 there is no source 2 and the result is A. It's equal to T3, there is no source 2 and result is A. So this is how you are going to represent the quadruples. Now let's see the triples. What is this triple? So here the triples is nothing but the name itself is saying it is having 3 fields. 3 fields. So what are the 3 fields for these triples? The 3 fields are nothing but operator, source 1 and source 2. That's it. There is no result for the triple. Okay. There is no saying result for this triple. Let's take the same example. A equal to minus B into C plus D. So convert it into 3 address code. So the 3 address code is represented as T1 is equal to minus B, T2 is equal to C plus D, T3 is equal to T1 into T2 and finally the A is equal to T3. Okay. So now using these statements you are going to represent the triples. How you are going to represent the triples? By using these statements. Let's see. So let me write the statements here. So every time turning back is difficult. Minus B, T2 is equal to C plus D and T3 is equal to T1 into T2 and A is equal to T3. Okay, but constructing the triples, you no need to take this productions help. You can take the quadruples help. Quadruples table help. So here the operator. So just like that quadruples, you need to write operator, source 1 and source 2. That's it. There is no result for here. Okay, and first 0. What is this operator here? Minus, and source 1 is B. There is no source 2. Next production. What is the operator here? Plus, source 1 is C and source 2 is D. Now coming to the next. So T1 and 2. Instead of writing, so operator is star. Instead of writing T1, you need to write the reference of T1. So what is the reference of T1 here? T1 is, this is the result. So the T1 reference is 0. Just write the reference here. And T2 reference is 1. Okay. Now coming to the third production. So equal to T3. So what is the reference of T3 here? T3 reference is 2. Just write 2 here. So this is how you have to construct the triples by using the 3 address code. Thank you.